Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, it is time to continue further, and today we are going to continue with the chapter Matrices of Class 12th Part 1 textbook. This session will be devoted to exercise 3.2 from the chapter Matrices, and let's begin with the first question over here. The first question from exercise 3.2 of Matrices is this, which says let A is some matrix, B is some other matrix and C is another matrix. Find each of the following. There are various parts in this particular question. First we have to find A plus B, then we'll be finding other things as well. Let's discuss this part first. What does this part say? For A, B and C given, how do we find A plus B? The matrices A and B can be added together if they have the same order. For adding or subtracting two matrices, their order must be same. That is very important. For adding two matrices, the order should be same. Order of A is 2 by 2. Order of B is also 2 by 2. And therefore, yes, they can be added together. Now, how do we add them together? We add them together by adding the corresponding elements. The corresponding elements means this A11 and this B11 get added together. A12, B12 get added together. A21 and B21, A21 and B21 get added together, and similarly A22, B22 get added together. So the matrix A plus B, would be equal to what? This can be written as A is 2, 4, 3, 2 first of all, and B, the matrix B, as you can observe, is 1, 3, minus 2, 5. This is matrix B, right? Addition of these two matrices is very simple. What we'll do is we'll add the corresponding elements, which is 2 plus 1 over here, 4 plus 3 over here, 3 minus 2 over here, and 2 plus 5 over here. This is how you add the two matrices. This is 3, 7, 1 and 7 over here. This is what you have. That's the sum of A and B, as you can observe, right? This is the first part of this question. For the same question, let us take a look at part 2. Find A minus B. Now, how do we find A minus B? The process is similar to finding A plus B. First of all, the order should be same, and as we know that the orders are same only over here. A minus B, let's write the two matrices first. A is 2, 4, 3, 2, and minus B is 1, 3, minus 2, 5. Right? This is what we have. These are the two matrices. Subtracting would be possible by subtracting the corresponding elements. 2 minus 1, this is what I get. 4 minus 3 is what I get over here. 3 minus 2 is what I get over here. 2 minus 5 is what I'll get over here. This is the matrix. This is the difference of A and B. This is A minus B. What is this further simplifying into? This is 1. 4 minus 3 is 1. 3 minus or minus 2, 3 plus 2, which is 5. 2 minus 5, which is minus 3. And yes, this is my answer for A minus B, as you can see over here. Next, let's take a look at this part, the third part. What does the third part say? This is 3A minus C. For A, B and C given, we have to find 3A minus C. Now, what does 3A imply? First of all, 3A has to be found. Now, 3A is obtained by multiplying each element of the matrix A, each element of this matrix by this scalar quantity 3. That's what we are supposed to do. So, 3A minus C, this is third part. 3A minus C, let's write it properly. This is 3 times matrix A. What is matrix A? 2, 4, 3, 2. Minus matrix C. C is that matrix over here. This is minus 2, 5, 3, 4. This is the matrix, right? So first we'll simplify this and then we'll subtract this one. How do we simplify this? This scalar quantity gets multiplied with each of the elements present in the matrix. This 3 gets multiplied with 2, this becomes 6. 3 gets multiplied with 4, this becomes 12. 3 times 3 is 9. 3 times 2 is 6. I hope that's clear. Yes, that's pretty simple. and then we have minus 2, 5, 3, 4, which is further equal to, which implies 3a minus c is equal to 6 minus 2. Right? Let's subtract the corresponding elements. 12 minus 5 is what you'll obtain over here. 9 minus 3. 6 minus 4. This gets simplified to what? 6 minus or minus 2? 6 plus 2, which is 8. 12 minus 5 is 7. 9 minus 3 is 6. 6 minus 4 is 2. And yes, this is my answer for this third part, 3a minus c over here. Right? Let's take a look at this fourth part. What are we asked? We are supposed to find the product AB. Now the product AB can be obtained easily if the product exists first of all. And when can you find the product? For product of two matrices A and B having order m by n and p by q, this and this should be equal. That is, n should be equal to p. This is a row by column multiplication, and yes, the number of columns in this should be equal to the number of rows in this, and then the product that obtains C will have order m by q. The product will have order m by q, this and this over here. This will be the final order of the product, right? And m and n and p should be equal. That's the important condition. Here, as you may observe, both the matrices are having A and B, both are having order 2 by 2. So yes, 2 and 2 are equal, that's something which is required, and the final order of the product would be 2 by 2, as you can observe from the outside numbers. The product AB, let's take a look at the product AB. How do we find the product AB? Let's write this 2, 4, 3, 2 multiplied with 1, 3 minus 2, 5. We study row by column multiplication, and row by column multiplication implies that the first row gets multiplied with first column to give us the first element of the product. This element, the first row and second element, the column present in the first row and second column is obtained by multiplying the first row with the second column, right, and adding the corresponding terms. So let's do it. This is first row, first column, we get this one, 2 times 1 plus 4 times minus 2. This is what you have. Then this element, the first row, second column, 2 times 3 plus 4 times 5 is what you get over here. Right. Next, this one, second row, first column is what you do. 3 times 1 plus 2 times minus 2. This is the product that we obtain. Then 3, 2 gets multiplied with this 3, 5, which is 3 times 3 plus 2 times 5. This is the product of the matrices A and B. This is the product of the matrices A and B, which implies, let's simplify this further, AB, the product AB is equal to what? This is 2 minus 8. This is 6 plus 20. This is 3 minus 4. What about this? This is 9 plus 10. And let's simplify this. One more step remains. Let's simplify this further. This is minus 6. This is 26. This is minus 1 and this is 90. That is the answer for this part over here. Fourth part, the product AB is being asked over here, right? Let's take a look at this over here. Fifth part, BA. How do we find BA? Process once again is very simple, very easy. Let's multiply B and A. This time B will come in the front. We have 1, 3 minus 2, 5 gets multiplied with 2, 4, 3, 2. This matrix over here. The product can be obtained by multiplying this row with this column for the first element. First row, second column, second row, first column, and second row, second column. That's what you are supposed to do. Let's multiply the first row, first column to obtain this element. 1 times 2 plus 3 times 3. Then we multiply the first row and the second column. We get 1 times 4 plus 3 times 2. Let's multiply second row, second column. Minus 2 times 2. Okay, this is minus 2 times 2 plus 5 times 3. And here what you get is second row, second column, which is minus 2 times 4 plus 5 times 2. This is what you get. Right? Observe this carefully and then it is pretty easy to solve. This is 9 plus 2, 11. This is 4 plus 6, 10. This is 15 minus 4, 11. This is 10 minus 8, which is 2. And yes, that is my correct answer for this product, BA over here. You can take a look at this complete thing. Okay, is that all? Yes, that is all in this question. Let us take a look at this question. Next. Compute the following. AB minus BA plus AB, BA. We're supposed to add these two matrices, and addition of these two matrices is not a difficult thing. It is pretty simple. Addition of these two matrices is pretty simple. What you do is you simply add the corresponding elements. A plus A, B plus B, minus B plus B, and A plus A. This is what you obtain on adding. Simplify it further, and what you get over here is this is 2A, this is 2B, this is 0, this is 2A. And yes, that is my answer for this question over here. Part 1 of this second question. Let's take a look at part 2 for this. Once again, we have a 2 by 2 matrix over here and a 2 by 2 matrix over here. Let's add the two matrices and simplify. What do we get? Add the corresponding elements. This element A square plus B square gets added with 2AB. So what do we have is A square plus B square plus 2AB. Next, this B square plus C square, we add 2BC. Next, A square plus C square minus 2AC. And A square plus B square minus 2AB is remaining. This is the last element, right? What does this simplify into? This is A plus B whole square. As you can clearly observe, A square plus B square plus 2AB is simply A plus B whole square. This is B plus C whole square. This is A square plus C square minus 2AC, which is nothing but A minus C whole square. A square plus B square minus 2AB is nothing but A minus B whole square. That's what we obtain over here. Right? That's the complete answer. Yes, that is the final answer for this question over here. Let us take a look at this third part for second question. So here we have a 3 by 3 matrix and another 3 by 3 matrix. We're supposed to add these two matrices, and addition of these two matrices is not difficult at all. We'll add the corresponding elements. Let's show it. Minus 1 plus 12. Right? A11 and B1. Then first row, second column, first row, second column. What do we have? First row, second column. This is 4 plus 7 over here. Then minus 6 plus 6. This is what we have over here. Right? What next? This is 8 and 8. Let's add them together. 8 plus 8. This is 5 and 0. Let's add 5 and 0. This is 16 and 5. Let's add 16 and 5. The corresponding elements, that's what we are adding. This 2 and 3 get added. This 8 and 2. This 5 and 4 get added. This is what we have. Right? What else? Simplify this expression. This is 12 minus 1, which is 11. 4 plus 7 is 11. 6 minus 6 is 0. What next? 8 plus 8 is 16. 5 plus 0 is 5. 16 plus 5 is 21. 2 plus 3 is 5. 8 plus 2 is 10. And this is 9. And yes, that is my answer for this question over here. The sum of these two matrices of orders 3 by 3. Let us take a look at this one. Add these two matrices. We have two 2 by 2 matrices. Very simple to add, right? The first A11 gets added with B11. We have a cos square x plus sine square x. Then we have a sin square x plus cos square x. Okay. Then we have a sin square x plus cos square x. Okay. And cos square x plus sin square x over here. That's pretty interesting. Each and every term is cos square plus sin square, cos square plus sin square, cos square plus sin square, cos square plus sin square. And what is cos square x plus sin square x equal to? Yes, we know that. This is equal to 1. So each term in this matrix is equal to 1. In this 2 by 2 matrix, each term is equal to 1. And that is the final answer for this question over here, this part, this fourth part of question 2. Let us take a look at this question. Compute the indicated products. Okay. Okay, this is a product of two 2 by 2 matrices. Okay, let's try to multiply these two matrices. The process of multiplication is pretty simple. What we do is a row by column multiplication. This first row gets multiplied with the first column to give us the first element. The first row gets multiplied with the second column to give us the next element. Then second row gets multiplied with the first column and second row gets multiplied with the second column. Let's write the product of these two matrices over here. A, B gets multiplied. A times A plus B times B is what you get. Next, let's multiply this with this. A times minus B, okay, plus B times A is what I get over here, right? Then minus B times A plus A times B is what I get over here. This row gets multiplied with this minus B times minus B plus A times A. These are the two, this is the final product of this, right? Simplified further, this is A square plus B square. What is this? This is minus AB plus AB, which is 0. Minus AB plus AB, which is 0. This is B square plus A square. I can write it as A square plus B square. That's the product of these two matrices given. Right, that's the final answer for this part over here. Next, let us take a look at this part. What does it say? Compute the indicated product once again, and the matrix, the two matrices that we have, what are the possible orders of these two matrices? Mind you, for product of two matrices A and B, the number of columns in this should be equal to the number of rows in this, that is M by N is one of the possible orders. This is P by Q. Then M, N and P should be equal. This is important. They should be equal. Right? That is important. So what do we have over here? This is a 3 by 1 matrix. This is a 1 by 3 matrix. Yes, 1 and 1 are equal. The final order that will obtain by multiplying these two matrices would be 3 by 3, as we know. Right? So what do we have? The product would be equal to the product. In the second part, what do we have is 1, 2, 3. This is one matrix. The other matrix is 2, 3, 4, and the product is obtained by multiplying the first row with the first column 1 times 2. Okay. The first row with the second column, which is 1 times 3. The first row with the third column, which is 1 times 4. Okay. This is not 1.2. This is 1 times 2. Okay. Similarly, the second row is obtained by multiplying the second row with the second column 2 times 2. 2 times 3. 2 times 4. Similarly, the third row gets multiplied with the first column, second column, third column to give us 3 times 2, 3 times 3, 3 times 4, and the final product of these two matrices would be actually, on simplification, we'll get this is 2, 3, 4. 2 times 2 is 4, 6, 8. 3 times 2 is 6, 9, 12. That is the final answer for this question, for this product over here. Is that all? Yes, that is all in this part. Let us multiply these matrices now. What is the order of this matrix? This is a 2 by 2 matrix. This is a 2 by 3 matrix. This is equal, okay. And the final order of the matrices would be, of the product would be 2 by 3. So, how do we multiply? Once again, process is very simple. What we'll do is multiply this row with this column. 1 times 1 plus this minus 2 times 2. This is the first row, first column element. Okay. Next, what do we have over here is first row at second column. This is 1 times 2 plus minus 2 times 3. What next? You are supposed to multiply this first row with this column, third column, and get this element over here, which is 1 times 3 plus minus 2 times 1. Is that all? Yes. But this is just the first row. Let's find the second row. This 2, 3 gets multiplied with 1, 2. 2 times 1 plus 3 times 2. Okay. This 2, 3 gets multiplied with another 2, 3 over here. So 2 times 2 plus 3 times 3. 2, 3 gets multiplied with 2, 3. For this element, this 2, 3 gets multiplied with 3, 1. 2, 3, 2 into 3 and 3 into 1. That's the product. So what do we get over here on simplification? This is 1 minus 4, which is minus 3. This is 2 minus 6, which is minus 4. This is 3 minus 2, which is 1. This is what we have. This is 2 plus 6, which is 8. This is 4 plus 9, 13. This is 6 plus 3, 9. And yes, that is the complete product of these two matrices given. Right? This is the third part for this question over here. Let us take a look at fourth part of this question. A product of two 3 by 3 matrices. Okay, let's take a look at this product. How do we multiply these two matrices? What we do is we simply multiply this first row with this first column. Then multiply this first row with the second column, multiply this first row with the third column, you'll get the complete first row. For second row, multiply second row with the first column, second row with the second column, second row with the third column to get the 3 terms. For the third row, we will have to multiply this row with this column, this row with this column, this row with this column. That is what we are supposed to do. Let's do it. Okay. So first row with the first column, 2, 3, 4, 2 times 1 plus 3 times 0 plus 4 times 3 is what I get. Observe carefully. 2 times 1, 3 times 0, 4 times 3. For this element over here, the first row gets multiplied with the second column. This 2 gets multiplied with minus 3. This 3 gets multiplied with 2. And this 4 gets multiplied with 0. Next, this first row gets multiplied with this third column. What do we have over here is, let's take a look at this. 2 times 5, 3 times 4, 4 times 5. This is what I have, right? What next? This second row gets multiplied with the first column over here. So 3 times 1, 4 times 0, plus 5 times 3. Okay. This element over here is multiplied by obtaining the obtained by multiplying this second row and the second column, which is 3 times minus 3 plus 4 times 2, 4 times 2 and 5 times 0. This is what I'll be having, right? And this one over here is obtained by multiplying this second row with the third column, which is 3 times 5 plus 4 times 4 plus 5 times 5. This is what I have, right? That's what we have. What about the last row? Third row gets multiplied with this column. 4 times 1, 5, 0, 6, 3. 4 times 1 plus 5 times 0 plus 6 times 3. This is what I have, right? What next? This 4, 5, 6 gets multiplied with minus 3. 4 times minus 3 plus 5 times 2 plus 6 times 0. This is what I have, right? And the third row gets multiplied with third column to give us this element, which is 4 times 5 plus 5 times 4 plus 6 times 5. Yeah, right? 4, 5, 6, 4, 5, 6, 4, 5, 6, 3, 4, 5, 3, 4, 5, 3, 4, 5, 2, 3, 4. Let's just check that. 2, 3, 4 and 2, 3, 4. Right. So we have written each term as product, sum of product of elements, and now let's simplify this further. What is this? This is 2 plus 0 plus 12. What is this? This is 3 plus 0 plus 15. What is the last element of this first column? This is 4 plus 0 plus 18. What about this? This is minus 6 plus 6 plus 0. Okay, this is minus 9 plus 8 plus 0. Then you have minus 12 plus 10 plus 0. Okay, what next? You have 10 plus 12 plus 20. You have 15 plus 16 plus 25. That's what you have, right? What next? This is 20 plus 20 plus 30. And now a final step of simplification remains and you get your final answer. What is that? This is 14 over here. 2 plus 12 is 14 over here. Minus 6 plus 6 is 0 over here. This is 10, 12, 20, 42 over here. This is 3 plus 15, which is 18 over here. This is minus 1. This is 30, 56. Then you have 22 and minus 2, and what you have over is 17. That's the product of these two matrices as given on the board, right? That's the final answer. Yes, this is the final answer for this question over here. Next, let us multiply these two matrices over here. So what is the order of first matrix? Let's take a look at the order of first matrix. This is a 3 by 2 matrix. This is a 2 by 3 matrix. 2 and 2, since they are equal, so the product is possible first of all, and yes, the final order would be 3 by 3. Let's multiply these two matrices together. So what we do is we multiply the first row with the first column, which is 2 times 1 plus 1 times minus 1. And since we have multiplied many matrices up till now, I hope you are well aware of the process, right? So, okay, let me solve this one also in proper detail. 2 times 0 plus 1 times 2. Then you have 2 times 1 plus 1 times 1. That's what we have, right? Then 3, 2 gets multiplied with this. 3 times 1 plus 2 times minus 1. 3 times 0 plus 2 times 2. 3 times 1 plus 2 times 1. This is what I'll be getting over here. What about this element? This row gets multiplied with this. Minus 1 times 1 plus 1 times minus 1. What next? Minus 1 times 0 plus 1 times 2. What next? Minus 1 times 1 plus 1 times 1. This is what I'll be getting, right? On simplification, what does it convert to? This is 2 minus 1, which is 1. This is 0 plus 2, which is 2. This is 2 plus 1, which is 3. Okay, simplified, right? This is 3 minus 2, which is 1. This is 0 plus 4, which is 4. This is 3 plus 2, which is 5. This is minus 1, which becomes minus 2. This is 2. This is minus 1 plus 1, which is 0. And as you may observe clearly, that yes, this is the final answer for this fifth part over here. Let's solve this one for indicated product. There are two matrices given. This is a 2 by 3 matrix. This is a 3 by 2 matrix. This 3 and 3, since they are equal, the product is possible, yes. Okay, and the final order that will obtain is 2 by 2. Okay, so we'll obtain a 2 by 2 product. Let's try to obtain that 2 by 2 product. Okay, what do we have over here? For this element, you need to multiply this first row with this first column, right? And this is 3 times 2 plus minus 1 times 1 plus 3 times 3. That's what you have, right? For this element over here, the first row gets multiplied with the second column. This is 3 times minus 3 plus minus 1 times 0 plus 3 times 1. That's what we have, right? Okay, what next? The second row, first column, minus 1 gets multiplied with 2 plus 0 gets multiplied with 1 plus 2 gets multiplied with 3. This is what we'll acquire. Next, the second row and second column get multiplied. Minus 1 gets multiplied with minus 3. 0 gets multiplied with 0 plus 2 gets multiplied with 1. This is what I obtain. This is the 2 by 2 matrix that we are looking forward to, right? The product matrix. What does this simplify to? This is 6 minus 1 plus 9. This is minus 2 plus 0 plus 6. What about this? This is minus 9 plus 0 and plus 3. That's what you have, right? This is 3 plus 0 plus 2. The final product of the given two matrices would be 9 plus 6, 15 minus 1 is 14 over here. This is minus 6. This is 6 minus 2, which is 4, and 3 plus 2 is 5. That is the answer for this question over here, as you can see clearly, right? That's the complete solution. Yes, that's the complete solution of this part. Let's take a look at this question. Fourth, if A is equal to this matrix, 3 by 3 matrix, B is another 3 by 3 matrix, and C is also a 3 by 3 matrix, then compute A plus B and B minus C. Okay, we are supposed to find A plus B and B minus C first. Also, we are supposed to verify whether A plus B minus C is equal to A plus B minus C. Okay, that's what we are supposed to find. So, let's try to find, first of all, can we find A plus B and B minus C very easily? Yes. We can find A plus B. A plus B is something which we require over here as well. B minus C is something that we require over here. So, we'll find A plus B first. A plus B. Now, A is a 3 by 3 matrix, B is a 3 by 3 matrix. The sum of these two matrices would be obtained by adding the corresponding elements. Okay, let's add them together. This is 1 and 3, the sum is 4. Are we adding them in one step? Yes, that's also possible. We can do it. Then 2 minus 1, which is 1, minus 3 plus 2, which is minus 1. Come on, catch up, right? 5 plus 4 is 9. 0 plus 2 is 2. 2 plus 5 is 7. Right? That's simple. Then you have 1 plus 2, which is 3. Minus 1 plus 0, which is minus 1. Then you have 1 plus 3, which is 4. This is A plus B for us. This is A plus B for us. What about B minus C? B minus C. B minus C will be obtained by subtracting this from this, right? Corresponding elements of each. 3 minus 4. So should I write the calculation step in between? I think we can skip that. Or let's write it maybe. 3 minus 4. Since subtraction will be an issue for some people, let me write it. Minus 1 minus 1. 2 minus 2. This is what I have, right? Okay, let's write it a bit closer. Minus 1. This is 2 minus 2. Okay, what next? 4 minus 0. 2 minus 3. 5 minus 2. What about the third row? This is 2 minus 1. This is 0 minus of minus 2. 3 minus 3. What is this equal to further? This 3 minus 4, which is minus 1. This is minus 2. This is 0. 4 minus 0 is 4. This is minus 1. This is 3. 1 and 2 and 0. This is the matrix B minus C. Okay. This is what we obtain as B minus C. Next, since we have found A plus B and B minus C, we are also supposed to verify something. So let's continue verifying that. For verification, what we need is, first let us find the LHS to prove, to verify basically, A plus B minus C is equal to A plus B minus C. Let us simplify the LHS first. LHS is A plus B minus C. So we have a separate and a B minus C over here. Let's add them together. What do we have over here is 1, 2 minus 3, and this is 1, 2 minus 3. This is 5, 0, 2. This is 1 minus 1, 1. And just a minute, this B minus C is equal to this matrix. Minus 1, minus 2, 0. 4 minus 1, 3. 1, 2, 0, as you can see over here clearly. Add these two together. What do we get? This is 1 minus 1, which is gone, 0. This is 2 minus 2, gone, 0. This is minus 3 plus 0, which is minus 3. Adding the corresponding elements of the second row, 5 and 4 add up to 9. 0 and minus 1 will give me minus 1. 2 and 3 added together will give me 5. Then you have a 1 plus 1, which is 2. Minus 1 plus 2, which is 1. And 1 plus 0, which is 1. This is what we have. Right? The LHS is equal to this matrix. What about the RHS? RHS is equal to A plus B minus C. Now A plus B is this matrix, C is this matrix. Let's write them first. So A plus B is this 4, 1, minus 1, 9, 2, 7 and 3, minus 1, 4. Minus C matrix. C is that matrix, right? What do we have over here is 4, 1, 2, 0, 3, 2, 1 minus 2, 3. And subtract the corresponding elements to get the final result. 4 minus 4 is 0. 1 minus 1 is 0. Minus 1 minus 2 is minus 3. That's what you obtain. 9 minus 0 is 9. 2 minus 3 is minus 1. 7 minus 2 is 5. That's what you obtain, right? The third row, 3 minus 1 is 2. Minus 1 minus of minus 2. Okay. Minus 1 plus 2 is actually 1. 4 minus 3 is 1 over here. Right? The LHS has been simplified to a matrix. The RHS has already simplified to a matrix. Are they equal? Can you please observe 0, 0, minus 3, 9, minus 1, 5, 2, 1, 1. Yes, they are equal. Hence, verified. LHS is equal to RHS, verified. You see over here, what do we have is A plus B minus C. The brackets can be manipulated, right? A plus B minus C or A plus B minus C. What you are actually doing is you are applying some kind of a distributive law over here, right? Some kind of distributive law in some form. Actually, distributive law in general talks about, in case of addition, we talk about A plus B plus C. So we can add B and C together and then we can add that sum to A, or you can add A and B together that add that sum to C. Here, the person has introduced something called minus C also. So you can imagine distributive law in a particular way over here. Distributive law, yes. Distributive law is being applied over addition for these three matrices, A, B and minus C, right? So we can add these two, then add this, or we can add these two and then add with A, right? So distributive law is possible on addition, over addition. Yes, for matrices, distributive law holds for addition, right? And let me get aside for a bit for you to take a look at the complete solution once again. And yes, that is all in this question for us. Let us take a look at this question. If A equals this big matrix and B is another big matrix, then compute 3A minus 5B. That's what we are supposed to find. Now 3A minus 5B, if you see the two matrices, 3A minus 5B would not be very difficult. 3A, first we will have to simplify this 3A, and how do we get 3A? By multiplying each element of the matrix A by 3. How do we get 5B? By multiplying each element of this matrix B by 5. Let's do it. 3A minus 5B would be equal to what? So let's simplify 3A first. 3 times each of these elements. Let me write first of all this. Let me write this first of all. 3 times. This is 2 by 3. This is 1. This is 5 by 3. Then you have a 1 by 3, 2 by 3, 4 by 3. These are the elements that we have, right? And 7 by 3, 2, 2 by 3. Minus 5 times B. What do we have over here is? Let's write the matrix B. Matrix B has elements 2 by 5, 3 by 5, 1. This is 2 by 5, 3 by 5, 1. This is 1 by 5, 2 by 5, 4 by 5. Then you have 7 by 5, 6 by 5, 2 by 5. What does this simplify into? 3a minus 5b gets simplified into, let's multiply 3 with each of these elements. This matrix becomes 2 by 3 times 3 would be 2. Okay. This becomes 3 times 1, which is 3. This becomes 5. Pretty simple. This is 1, 2, 4. This here is 7. 3 times 2 is 6. 2. Minus another one. 5 gets multiplied to each term. This becomes 2, 3, 5. This becomes 1, 2 and 4. This becomes 7, 6 and 2. This is what we have. Let's take the difference of these two matrices. 2 minus 2, which is 0. 3 minus 3, which is 0. 5 minus 5, which is 0. Very interesting. Okay, 1, 2, 4, 7, 6, 2. Everything is 0. These two matrices are exactly same. And what you obtain is a null matrix, as you can see over here. A 0 matrix, as you can see over here, of order 3 by 3. That's what you obtain over here. And that's the complete solution. Let me get aside for a bit for you to take a look at this complete solution. And yes, that is all in this question over here. Let's solve this question. Simplify cos theta times cos theta sin theta minus sin theta cos theta plus sin theta times this another expression over here. And how do we simplify this? Okay, there are scalars getting multiplied to the matrix, and since this quantity gets multiplied with this matrix implies that this cos theta will get multiplied with each term in this matrix. Let's do it. Cos theta times cos theta is cos square theta. Cos theta times sin theta is cos theta times sin theta. Cos theta minus sin theta, the product would be minus, okay, and let me write this term over here, cos theta times sin theta. What about the last term? This is cos theta times cos theta, which is cos square theta. This is the first matrix after multiplying with that cos theta outside. Let's multiply the sin theta in the other matrix and see what do we get. Sin theta times sin theta is sin square theta. Sin theta times cos theta is sin theta into cos theta. What next? Sin theta into minus cos theta is minus sin theta times cos theta. And sin theta times sin theta is sin square theta. Can we simplify this further? Yes. Some application of trigonometry. Yes, little bit. This is cos square theta and sin square theta. We are supposed to add them. Cos square theta plus sin square theta is what we obtain. And yes, we remember that cos square theta plus sin square theta is equal to 1. We'll write that also. Cos theta sin theta, the product, minus sin theta cos theta product, that is simply 0. Right? It's simply 0. Minus cos theta sin theta plus sin theta cos theta is 0 once again. Cos square theta plus sin square theta is what I obtain over here. And since sin square plus cos sin square theta plus cos square theta is equal to 1, this becomes 1, 0, 0. This is 1. Equal to the identity matrix of order 2. This is identity matrix of order 2. That's what we obtain over here. Is that all? Yes, that is all in this question, as you can observe clearly. Let us discuss this question over here. What does this question say? Find x and y if, first part, we are looking at the first part of this question number 7, and the first part says x plus y equals 7025 and x minus y equals 3003. So you can observe clearly that x and y are basically two matrices, and if we are adding these two matrices, we are getting a 2 by 2 matrix. So x is also 2 by 2 matrix, y should also be a 2 by 2 matrix. And these are two simple equations, right? We can easily solve those two equations because there are two unknowns and two equations which can be easily solved by elimination, substitution, something of that sort, right? So let's write the two equations and solve them properly. How do we approach this equation? Let's see. This says that x plus y is equal to 7, 0, 2, 5, this matrix. X minus y is equal to another matrix. What is that matrix? This is 3, 0, 0, 3. And since this is known to us, what I'll do is, this is equation number 1, let us say. This is equation number 2, let us say. And since these are two equations, as written over here, what we can do is we can simply add these two. Now what will you get by adding these two? On the LHS you may observe that this term of y will get cancelled by adding this. X plus y plus x minus y will be actually equal to 2x, and that will further be equal to the sum of these two matrices. What about the sum of these two matrices? What we can do is, we can add the corresponding elements directly and obtain, this is 7 plus 3, which is 10 over here. This first element A11 would be actually 10. This element would be 0 plus 0, which is 0. The element over here would be 2 plus 0, which is 2, and the element over here would be 5 plus 3, which is 8. Okay, and implies you can get the value of x by dividing with 2 on both sides. Dividing by 2, take this 2 over here, what you will get is x equals 1 by 2, 10, 0, 2, 8, which implies that x will be equal to what? X will be equal to, this 1 by 2 gets multiplied with each term inside the matrix, and that will give me 10 by 2, which is 5, 0 by 2, which is 0, 2 by 2, which is 1, and 8 by 2, which is 4. This is the matrix X for us. Okay, and once we have obtained this matrix X, we can easily get Y by substituting it in any of these equations, right? Or somebody else would say, sir, why substitute? Why not simply subtract these two equations? We can subtract. Subtracting equation 2 from equation 1, what you get is x plus y minus x, and minus or minus becomes plus y. This will be equal to 2y. 2y is equal to what? 2y is equal to difference of these two, that is 7 minus 3. 7 minus 3 would be 4. 0 minus 0 would be 0. 2 minus 0 would be 2. 5 minus 3 would be 2. And therefore y would further be equal to, let's divide each element by 2. This is 2, 0, 1, 1. That is the matrix Y for us. This is the matrix X for us. And yes, those are corresponding X and Y that we required in this question over here. Let me get the side, and you can take a look at this complete question over here. Right? Simple method of finding X and Y. Yes? Yes. Let's discuss this question. 7th part 2, where we are supposed to find X and Y if 2x plus 3y is this matrix and 3x plus 2y is this matrix. You may observe that x and y will be 2 by 2 matrices. There will be 2 by 2 matrices. This 2 by 2 matrix multiplied with 2, that is a scalar quantity, will be a 2 by 2 matrix. Another 2 by 2 matrix should be here, yes, and that sum would be 2 by 2 matrix, right? So how do we approach this question? Once again, the approach is very easy. We have to use elimination to get the values of x and y. And elimination in this case would not be very difficult. What we are supposed to do is, let's use elimination somehow. Now you may observe that direct addition or subtraction of anything, any of these equations will not give me either x or y. So what do we do in this case, right? You observe this is 2x plus 3y, 3x plus 2y. What I observe is, can I do this? Let's do one thing. What are we supposed to do? Let's add these two equations. Let's say this is equation number 1, this is equation number 2. The given equations, these are equation number 1 and equation number 2. And let's add them together. 1 plus 2. What is the sum of equation 1 and equation 2? What does that give me? That gives me 2x plus 3x is actually 5x plus 3y plus 2y, which is 5y. That is equal to the sum of these two matrices on the right hand side. What is that? This is 2, 3, 4, 0, 2 minus 2, minus 1, 5. 2 plus 2 is actually 4. 3 minus 2 would be 1, 4 minus 1 would be 3, and 0 plus 5 would be 5. This is what I'll get. This is 5x plus 5y, as you may observe over here. And from here, I can easily get the value of x plus y by dividing with 5 throughout. What will that be? This will be 1 by 5 times this matrix 4, 1, 3, 5, which can further be simplified by maybe multiplying this 1 by 5 inside, right? 1 by 5 will get multiplied with each and every term inside the matrix, and what you will be getting is 4 by 5, 1 by 5, 3 by 5 and 5 by 5, which is 1. This is the matrix that you will get. This is x plus y for us. Okay, what else? What else? I want to apply a similar kind of operation, right? What is the operation that I want to apply? I have plenty of choices from here. One of the choices that I have is, why not subtract these two? Why not subtract these two? How do we want to subtract? Let's subtract equation 1 from equation 2. Equation 1 is subtracted from equation 2. So this minus this. Now what do I get in this case? This is 3x minus 2x, which will be x. This is 2y minus 3y, which will be minus y. And what will you get over here is this matrix. This is 2 minus 2. That will be 0. Corresponding terms get subtracted, right? This is minus 2 and minus 3. What will that be? Minus 5. This is minus 1 minus 4, which will be minus 5. This will be 5 minus 0, which is 5. This is the value of x minus y, as you can see over here, right? We know x plus y and we know x minus y. This is, let us say this is equation number 3. This is equation number 4. And since we know x and y, x plus y and x minus y, we can easily find the value of x and the value of y by maybe adding and subtracting these now. Let's add equation 3 and equation 4. What does that give me? X plus y plus x minus y, which will be equal to 2x. That is simply equal to sum of these two. Now corresponding elements, 4 by 5 gets added with 0. What you get is 4 by 5. 1 by 5 minus 5 is what we have over here. 1 by 5 minus 5 is what we have over here. 3 by 5 minus 5 is what we have over here. And 1 plus 5, which is, this is 3 plus 4. 1 plus 5 is what we have. 1 plus 5 is 6. That's what you'll be having over here, right? What else? This is 4 by 5, which is very simple. Okay. Taking the LCM, 1 minus 25. 1 minus 25 would be minus 24. This is minus 24 by 5. 3 minus 25, which is minus 22 by 5. This is 6 over here. And this here is the value of 2x. Since we already know 2x, can we easily find x? Yes. This gives me divided by 2 on both sides. And what you get is, let's divide by 2 inside the matrix. And the value of x, the matrix x would be 2 by 5, minus 12 by 5, minus 11 by 5, 3. This is matrix x for us. This is matrix x for us. This is matrix x. Right? Okay. What next? Can we also find matrix y easily? Yes. We can find matrix y easily using one of the approaches. What are the different approaches that we can follow? We can subtract these two and we can get the value of y from here, 2y, by subtracting this and this, right? So equation 3 minus equation 4 would be actually giving us 2y. Let's do it, right? Let's do the calculation over here. Equation 3 minus equation 4, that will give me 2y in the LHS. Can you see this minus this? What will that be? X gets cancelled. Y minus or minus y would be 2y. And that will be equal to this minus this. Okay. So this 4 by 5 minus 0 would be 4 by 5 only. Okay. 1 by 5 minus or minus 5 is plus 5, right? 1 by 5 plus 5, what is that? That is 26 over 5. 3 by 5 minus or minus 5, which will be 3 by 5 plus 5. What is that? 3 plus 25, which is 28 by 5. It's like this. Similar step to this. 1 minus 5, which will be minus 4. This is what you'll be getting. And on dividing both sides by 2, you get y is equal to this matrix. This is 2 by 5. Okay, there's pretty less space, but then we'll write it properly. This is 13 by 5. This is 14 by 5. This is minus 2. Okay, these are the matrices x and y. The matrix y is also obtained over here. Right. Once we are through with this, we have obtained x and y, yes, but can we also verify this given condition? Yes, we can verify this given condition, or we can verify this x and y, x plus y and x minus y and all. Right. So let's check whether 2x plus 3y is equal to this. Let us check first equation. What do we have? 2 times x would be 4 by 5 and 3 times y would be 6 by 5. 4 by 5 plus 6 by 5 would be actually 10 by 5, which is 2 here. The first term is okay. 2 times x, which is minus 24 by 5. Minus 24 by 5 plus 39 by 5. Minus 24 plus 19 plus 39. Minus 24 plus 39 would be equal to 15 upon 5, which is 3 over here. Okay, that matches properly. What about this one? 2 times x, which is minus 22. 3 times 14, which is 14 times 3 is 42. 42 minus 22 is 20 upon 5, which is 4. right? That matches properly. What else? 2 times x is 6, 3 times y is minus 6. Add them together, what you get is a 0. So yes, the given x and y have been verified for, the obtained x and y have been verified for this equation 1. We can also verify this for equation 2 as well. Let's verify for equation 2 as well. 3x plus 2y, let's do it. 3x, now 3 times this, 3, 2, 6 by 5, and 2 into 2, 4 by 5. 6 by 5 plus 4 by 5 is actually 10 by 5, which is equal to that 2 over there, right? Let's take this element. What is this? 3x, which is minus 36 by 5, and 2y is 26 by 5. So minus 36 by 5 plus 26 by 5, which is minus 36 plus 26 is actually minus 10 by 5, which is minus 2. This is equal to minus 2. What next? 3x plus 2y is minus 33 by 5 and 28 by 5, right? Minus 33 plus 28, which is minus 5 by 5, which will be equal to minus 1, as you can see. And the last term, what you get is 3x, 3, 3, 9 minus 2, 2, 4. 9 minus 4 is actually 5. Yes, this term is also verified, and therefore the values of x and y that we have obtained over here, so this simple idea are these. Okay, what else? Could we have solved in some other way? Yes, we could have used elimination in another way possible. What is that way possible? Let's take a look at this. We could have eliminated x and y by simply multiplying this equation by, let us say I multiply this equation by 3, okay, and this equation by 2. So multiplying this equation by 3 and this equation by 2, the coefficient of x would become 6 and the coefficient of x would also become 6. After that, what I do is I subtract these two equations. That is another possibility. That is another possibility, and the values of x and y that you will obtain will be exactly same. So another approach could be using that kind of elimination. I can get the value of x. Similarly, for getting the value of y, multiply this by 2, multiply this by 3. The complete equation, obviously, complete equation, right? And subtract them. To you, in that case, you will get the value of x easily, right? In one case, you will be able to eliminate x. In the other one, you will be able to eliminate y in a single step, and yes, you can get the values of x and y using that approach as well. Or simply, since 2x and 3y has some important things that we can add them to get the same coefficient of x and y, we will easily get x plus y, and we can subtract them to get x minus y easily. So I've used this approach, and which gives me the values of x and y in this manner, right? So that is all in this question. I'll get aside for a bit and you can take a look at the complete solution over here. Is that all? Yes, that is all for this question over here. Let's discuss this question. Find x if y equals 3, 2, 1, 4 and 2x plus y equals 1, 0, minus 3, 2. Now how do we approach this question? In this question, y is already given. Okay, since y is already given, we are only supposed to find x somehow. And finding x is not very difficult. We simply substitute the value of y, right? Simply substitute the value of y, or let's write it as y equals, this is 3, 2, 1, 4, 2x plus y equals this matrix over here. What is the matrix? 1, 0, minus 3, 2. This is equation number 1. This is equation number 2. What we do is, we can simply subtract 1 from 2. Equation 2 minus equation 1. What will that give me in the LHS? 2x plus y minus y. That will be equal to 2x. And this will be equal to this minus this, which is 1 minus 3, which is minus 2. Okay, this is one thing. 0 minus 2, which is minus 2. Okay. Minus 3 minus 1, which is minus 4. And 2 minus 4, which is minus 2. This is what I will be having. Right. Therefore, the value of x will be equal to, divide by 2, and what you get is minus 1, minus 1, minus 2, minus 1. This is the value of x that will be getting. Is that all? Yes, that is all in this equation, in this particular question for solving this equation over here, right? We directly get the values of x by simple elimination of y, right? That is all? Yes, that is all. Let us take a look at this 9th question of exercise 3.2. Find x and y if 2 times this matrix plus another matrix is equal to this. Now in this question, as you may observe, we have to simplify this expression, add it with this, and comparing the LHS and RHS, which are two 2 by 2 matrices, will have to actually equate each element. Okay, let's try to do that. what do we have over here is, let's simplify this. This is 2. 2 times 1 is 2, 2 times 3 is 6, 2 times 0 is 0, 2 times x is 2x, okay. Then you have another matrix over here which is y, 0, 1, 2 and which is equal to 5, 6, 1, 8 as you may observe clearly over here. That's pretty simple, right? Let's add the two matrices on the LHS next. And what you get is 2 plus y. Okay, 6 plus 0 is 6, 0 plus 1 is 1, 2x plus 2 is simply written as this. And if these two matrices are given equal, then corresponding element should be same. This 2 plus y is equal to 6. 6 is already 6, 1 is 1 and 2x plus 2 should be equal to 8. So therefore, we note that 2 plus y equals 5 and 2x plus 2 is equal to 8. This is what we note, right? From here, you can clearly see that y equals 3. From here, you can clearly note that y equals 3. And from here, you can note that 2x is equal to 6 or x is equal to 3. Please note this carefully. This is simple solution for getting the values of small x and small y, as you can see over here in this solution clearly. Let us take a look at this question. 10th. Solve the equation for x, y, z and t if this matrix is equal to this matrix. Right? This equation is satisfied. Now how do we approach this? Once again, we are supposed to simplify this LHS and equate it equal to the RHS. We can do it in two ways. One of the ways is you simplify this, you simplify this, you simplify this, then you add them together and make it equal to this. But since we are supposed to compare corresponding elements, at the end of the day we are supposed to compare the corresponding elements, why not do it directly? What do you mean by directly? Let me give you a glimpse. Shorter version of the solution. What you will do is, this is 2 times x, the first element. Let's focus on the first row, first column, this particular element, right? First row, first column, this here. So that here, that element would be actually 2 times x, right? 2 times x plus 3 times 1 is equal to 3 times 3. This is what I have, right? So from here, what I'll get is 2x equals 9 minus 3, which is 6, or the value of x would be 3. Just by comparing the first row, first column. This is what you'll obtain. Alright. So similarly, can I compare this, this and this, right? The first row, second column. Yes, I can compare that. On the LHS, you have 2 times z plus 3 times minus 1 is equal to 3 times 5. What you have is, this is 2z minus 3 is equal to 15, or z equals 18 by 2, which is 9. This is what you get. On the RHS, you will have 15 plus 3, which is 18, divided by 2, that is 9. The value of z can be obtained using this step, right? Very simple, yes. So let's compare element present at the location, second row, first column, at this location over here. What do you have on the LHS is 2y plus 3 times 0 is equal to 3 times 4. What you have is 12 minus 0 is equal to 2y. 2y equals 12, or y equals 6, or y equals 6. This is what you have, right? What next? Let's compare this element next. This is what remains. Let's try to compare this element as well. Yes. So this element would be 2t plus 3 times 2 is equal to 3 times 6. That's what you have in the RHS, right? So this is 2t plus 6 is equal to 18, or 2t is equal to 12. Implies t is equal to 6. T is simply equal to 6. That's what you have, right? T is simply equal to 6. And those are the values of x, y, z and t, as you can see over there. Right. Now this is one way of directly comparing the corresponding elements. This is what you can use, obviously. But in case you feel like solving it complete. So what I'll do is, I'll write the steps involved before this, right? In case you want that. So let's simplify this. 2x. You may observe that you will get the exact same thing that I've written over there. 2y, 2t. This is this matrix. Plus there's another matrix, 3 times 1, which is 3, minus 3, 0, 6. And what about the RHS? On the RHS, you have 3 times 3, which is 9, 15, 12, and 18. That's what you have, right? Multiplying this complete matrix by 3. This is 9, 15, 12 and 18. What you have in the LHS after this is 2x plus 3, 2z minus 3, 2y plus 0, 2t plus 6. And this here is equal to 9, 15, 12, 18. That's what you have. And after this, since you want to compare the corresponding elements, what you'll have is 2x plus 3 equals 9. 2x plus 3 is actually equal to 9. This is what you're getting over there anyhow, right? And that will give us x equal to 3. Is that okay, right? So after this, in this particular approach, what you'll get is 2x plus 3 equals 9. That's one of the equations. What will that give us? 2x equals 6 or x equals 3. That's what you'll be doing. Similarly, you can compare this element, the first row, second column, the second row, first column and the second row, second column to get the values of z, y and t correspondingly in that manner, right? X equal to 3. This is what you'll be getting. So is that all? Yes, that is all in this question. That's a complete solution. Let me get aside for a bit so you can take a look at the complete solution for this question over here. Let us take a look at this question, 11th. If x times this matrix plus y times another matrix is equal to this matrix, then find the values of x and y. Okay. How do we go about solving for x and y? What we can do is simplify this given equation. X times 2 by 3 plus y times minus 1, 1 is equal to 10, 5. So, let's compare. This is not 2 by 3, this is actually 2, 3. This is a matrix, this is another matrix, this is another matrix. Let's compare the first row, first column first. The elements present at the first row, first column. So equation 1, one of the equations that you will get is 2x plus, 2 times x, y times minus 1 would be this, is equal to 10. This is one equation that you will get, right? By comparing this, right? Another equation that you get is 3x plus y is equal to 5. These are the two equations that you obtain over here. This is equation number 1, equation number 2. And using these two equations, you are supposed to solve for the two unknowns x and y, and which is very simple to solve. Since you have already obtained these two equations, what I'll do is I'll add the equations 1 plus 2. On adding, as you may observe, y and y gets cancelled. This is 5x equals 15, giving me x equals 3. The value of x is 3. Once you get the value of x, can you also find the value of y? Yes. Substitute x in any equation. Equation 1 gives me 2 times 3 minus y is equal to 10. What does that further give me? 6 minus y equals 10, or that gives me y equals 6 minus 10, which is minus 4. That is my answer for this question. X is 3, y is minus 4, and that was all. That was asked in this question over here. That's all? Yes. Let us take a look at this 12th question of exercise 3.2. What does the question say? Given 3 times this matrix over here is equal to this matrix plus this matrix, find the values of x, y, z and w. Okay. How do we approach this question? The approach is similar to a few questions which you have seen in the past, right? So this is a 2 by 2 matrix multiplied with 3. So 3 will get multiplied with each term. On the RHS, you have sum of two 2 by 2 matrices. Okay. Let's compare the first row, first column, corresponding elements present over there, and get one equation. So what you have is, the first equation would be with this first one by comparing element present at A11 location, right? The first row, first column location. By comparing the elements on the LHS and the RHS, what you get is 3x is equal to 3 times x is equal to x plus 4. Okay, by comparing this. Let's compare the first row, second column. First row, second column, what you have is 3 times y is equal to, on the RHS, 6 plus x plus y over there, right? That's what you have over there. What next? Let's compare the second row, first column, A21. This is 3 times z, which is equal to minus 1 plus z plus w on the RHS. That's what you have on the RHS. Let's compare the second row, second column. And in the second row, second column, we have 3 times w is equal to 2w plus 3. Okay. And therefore, we obtain 4 equations. Okay. What about the solution of these equations? Since this equation only contains the variable x, we can easily find the value of x from here. This is equation number 1, by the way. 2, 3 and 4. These are 4 equations. From here you can easily get the value of x, equation 1. Using that x in this equation, you can get the value of y, right? So equation 2, with the help of equation 1, you can find the value of y. Equation 2 independent will not help. This contains 2 variables z and w, but this contains only one variable w. So using this, we can find w, and then using the value of w, I can find the value of z. That will be the process. Simple process, yes. So let's use equation 1. Implies 2x equals 4, which gives me x equals 2. That's the answer for this. X equals 2. Equation 2 further implies that 3y is equal to 6 plus x. X is 2 plus y. We have substituted the value of x over here. X is simply 2. Next, this y comes over here and this becomes 2y equals 8, which gives me y equals 4. Is that all? Yes. This gives me the values of x and y very easily. What next? We can further move on to equation number 4 directly. You've skipped 3? No, I have not skipped 3. I'll come back to 3 because 3 contains 2 variables, but it will require 4. The value of w can be found easily, right, from 4. Equation 4 implies w equals 3. Right? What I've done is 2w goes over there, that gives me w equals 3. Right. And equation 3 after that implies this is 3z minus z, 2z, or you can write 3z only. 3z equals minus 1 plus z plus w. The value of w is 3. The value of w is 3. This gives me 2z is equal to 2, or that gives me z equals 1. And yes, these are the values of x, y, z and w, as you can observe over here in front of you. Right? That's the complete solution for this question over here. Let us take a look at this question. If fx equal to cos minus sin x 0, sin x cos x 0, 0, 0, 1, show that fx times fy is equal to f of x plus y. This is what we are asked to do. This is a very special matrix. It is sometimes also referred to as the transformation matrix. Transformation matrix, yes. This kind of a matrix has its applications in transformation. In transformation, yes, transformation of axis and transformation of axis. And what kind of axis transformation are we talking about? We're talking about actually rotation of axis. Which axis? In the coordinate plane. A lot of complicated things are coming over here. It's not very complicated. You may remember the Cartesian plane, right? In the Cartesian plane, for any point located at some particular location with reference to some x and y axis, some coordinates would exist, right? In case you rotate, what do you mean by rotate? In case you rotate the reference that is the coordinate axis. Okay. Location of P, the new coordinates for that location of P, the new coordinates can be obtained with the help of this. Okay. And for a 2-dimensional plane, only this particular part would be required. But for 3 dimensions and in some particular coordinate system, yes, the cylindrical coordinate system, what you have is a difference. In polar coordinate system, what you have is you will require this particular kind of a axis, this particular kind of a transformation system, right? So is that all required? Is all of this information required for solving this question? No, nothing is required for solving this question. We can solve this question very easily over here. Let's approach the question. Okay, capital Fx is equal to this. So in this equation, what are we supposed to prove over here? Let's see. To prove, we are supposed to prove that fx times fy is equal to f of x plus y. This is what we are supposed to prove. Now f of x is simply this. F of y would be, actually you have to replace these x with y. Then you have to multiply and see whether it is equal to f of x plus y, which is this x being replaced by x plus y, this x being replaced by x plus y, x plus y, x plus y, x plus y. Okay. So let's begin with the LHS. Okay. LHS is fx times fy. Now what is f of x over here? This matrix. This matrix is cos x, sin x, 0. What is this matrix? Minus sin x, cos x, 0. This is 0, this is 0, this is 1. This is f of x, right? What is the matrix f of y? Equal to f of y is another matrix. This is in product. Another matrix where this x should be replaced with y. So this becomes cos y minus sin y. This is sin y. This is cos y, right? And rest of terms will remain as it is. This is 0, 0. This is 1. This will be 0, 0. That is it? Yes, that is it. What about the product of these two matrices? Let's write the product of these two matrices. This is a 3 by 3 matrix. This is another 3 by 3 matrix. And the product can be obtained by multiplying this row with this column to get the first element, A11, right? Let's do it. This is cos x, cos y, minus sin x, sin y. Okay. So let's write it minus sin x times sin y. Okay. This is this element. There's less lack of space, so I'm writing it in a compact form over here. What next? For this element over here, I'll have to multiply the first row with the second column. You get cos x minus sin y. So minus cos x sin y minus sin x cos y. This is the complete term, okay. What about the last term over here? This row gets multiplied with this. What you have is cos x times 0, okay, minus sin x times 0 and 0 times 1. That's pretty interesting. Cos x times 0 will be 0, minus sin x times 0 would also be 0, and 0 times 1 will also be 0. This is actually sum of 3 zeros, which is 0 only. Which will be 0 only. Yes? Yes, obviously. This is what you get. So that's the complete first row. Yeah, that's the first row. Let us draw the boundary of this matrix. What about the second row? Second row is obtained by multiplying the second row with the first column, with the second column, and once again with the third column. Let's multiply with the first column. What you have is sin x times cos y. Cos x times sin y plus cos x times sin y, and 0 times 0 is 0, right? What else? Let's multiply the first row with the second column. Sin x minus sin y, which is minus sin x sin y. Cos x cos y, so plus cos x times cos y. What next? This row gets multiplied with this. We have sin x times 0, which is 0. Cos x times 0 is 0. 0 times 1 is also 0. So this element over here would be actually equal to 0 only. Take a look at that once again. What next? For the third row, we need to multiply this with this, this again with this again with this. Right? Let's do it. So 0 times cos y is gone. 0 times sin y is gone. 1 times 0 is gone. This is all 0. Big 0 over here. Similarly, the second element in the third row, 0 times minus sin y is 0. 0 times cos y is 0. 1 times 0 is also 0. That's pretty simple, right? What about the last element? The third row, third column. 0 times 0, 0 times 0, 1 times 1. What will that be? That will be 0 plus 0 plus 1. This will be 1 over here. You can observe that easily? Yes, you can observe that very easily. What next? Can I simplify this expression somehow? Yeah. What is this? This is cos x cos y minus sin x sin y. Cos a cos b minus sin a sin b is actually equal to cos of a plus b, that is cos of x plus y. This here is actually equal to cos of x plus y. Yes? Yes. What next? Can I take a minus common from here, right? This is minus cos x sin y, sin x cos y, right? Let's take a minus common, and what we get is a sin x cos y plus cos x sin y, right? Let's take a minus common, and sin x cos y plus cos x sin y. What is that equal to? Sin x cos y plus cos x sin y will be equal to sin of x plus y, right? From trigonometry. This is 0 over here. I'm not worried about that 0. Okay, what about this? This is sin x cos y plus cos x sin y, which is obviously sin of x plus y, right? You see, this term is actually the negative of this term only. Okay, so this term is actually the negative of this term only. What about this one? This is cos x cos y minus sin x sin y. Same as this, right? This is cos x cos y minus sin x sin y, which is cos of x plus y. This is 0 again, and the last row is 0 0 1, as you can clearly observe from the top. And what is this equal to? Let's compare. Cos of something, cos of x. Instead of cos of x, you have a cos of x plus y. Instead of minus sin x, you have a minus sin x plus y. Instead of sin x, you have a sin x plus y. Instead of cos x, you have a cos x plus y. For these 0 0 1, you have a 0 0 1 correspondingly. So we have replaced this x by x plus y. We can replace this x by x plus y, and this can be written as f of x plus y. That is something which we wanted to prove, yes. And yes, we have started from the LHS and we have reached the RHS of this statement. And that's the complete proof of this question over here. Is that all? Yes, that is all for this question, as you can clearly see on the screen. Let's discuss this question. This 14th, show that part 1 is being asked that this product is not equal to this product. Now what does this statement mean? Let's take a look at this. Product of two matrices A and B, please observe, product of two matrices A and B, and what do you have over here? The same matrix is written first, the second matrix is written first, and the second matrix is first matrix is written second. The product of two matrices A and B is not necessarily commutative, is generally not commutative. That's what you mean to say, that the product of two matrices A and B, for two matrices A and B, the product AB is not equal to BA in general. In case for any particular matrices, this result is reversed. For example, if AB is equal to BA for some two matrices, then those matrices are said to commute with each other. But that happens in very special cases. In general, for any two matrices, AB is not equal to BA, and that's a similar thing which you are supposed to prove over here, right? So we'll have to solve the LHS separately, we'll have to solve the RHS separately, and then obviously we're not supposed to prove equal, we're supposed to prove unequal, right? So that will be very simple, I suppose. That's just not a big deal. So let's solve the LHS separately. What do we have in the LHS is 5 minus 1 6 7. This is first matrix. The second matrix is 2 1 3 4, right? So we are proving AB is not equal to BA actually. Let's do it, right? For this pair of matrices, right? Okay. So are we actually proving? No, we are just saying that AB and BA are generally not equal, and let's say this is true for this two matrices as well. What do we have? First row with the first column, 5 times 2 is 10, minus 1 times 3 is minus 3. Once again, 5 times 1 is 5, minus 1 times 4 is minus 4. Okay. 6 times 2 is 12, 7 times 3 is 21. 6 times 1 is 6, 7 times 4 is 28, and this is the matrix that I obtained on the LHS. What is that? This is 7, this is 1, this is 33, and this is 34. This is a matrix in the LHS. What about the matrix in the RHS? RHS is equal to what? RHS, the matrices are written in reverse order, and what you have is 2, 1, 3, 4 over here. The other matrix, 5 minus 1, 6, 7. That's what you have, right? That's what we have. What next? Let's multiply these two together. 2 times 5 is 10, 1 times 6 is plus 6. Okay. The first row gets multiplied with the second column. What you have is minus 2, and 1 times 7 is plus 7. The second row gets multiplied with first column. This is 15 plus 24. Next, 3 times minus 1 is minus 3, 4 times 7 is 28, and this is all that we have over here. What next? This is 16, this is 5, this is 39, and this is 28 minus 3, which is 25, and you may observe that LHS, that is that matrix, is obviously not equal to this matrix RHS, hence proved. This is a proof of not equal to. Okay, this was not equal to this. That's proved? Yes, that's proved. Is that all? Yes, that is all in this question. Let us take a look at this one. Show that the product this is not equal to this product. So we have a 3 by 3 matrix and another 3 by 3 matrix, and the product of AB is not equal to the product of BA, as we may observe over here. So once again, matrix multiplication is not commutative. We are taking a look at that particular result. Matrix multiplication is not commutative for these two matrices. Let's check it, right? Let's do it. Let me write the LHS first. What is the LHS? LHS is pretty simple. I can solve the LHS by multiplying these two matrices. Let's do it. The first row gets multiplied in the first column, and what you obtain is 1 times minus 1, which is minus 1, 2 times 0, which is 0, 3 times 2, which is 6. Is that simple? Yes. Okay, let me get rid of this line. What about this element over here? First row gets multiplied with the second column. Matrix multiplication has to be done very smoothly, very properly. Don't make any mistakes in this. 1 times 1 is 1, 2 times minus 1, 3 times 3 is 9. Okay. The first row gets multiplied with the third column to give me this. What you get is 1 times 0 is 0, 2 times 1 is 2, 3 times 4 is 12. This is what I'll be getting. Let's take a look at the second row now. The second row gets multiplied with this. 0 minus 1 is 0, 1 times 0 is 0, 0 times 2 is 0. Okay. There are two zeros, which makes the multiplication pretty easy. 0 times 1 is 0, 1 times minus 1 is minus 1, 0 times 3 is 0. Okay. 0 times 0 is gone, plus 1 times 1 is 1, and 0 times 4 is 0. This is what you get. The third row, 1, 1, 0 gets multiplied with this. 1 times minus 1 is minus 1, 1 times 0 is 0, 0 times 2 is 0. Next, 1 times 1 is 1, 1 times minus 1 is minus 1, 0 times 3 is 0. 0 times 3 is 0, as you may observe over here. Next, 1 times 0 is 0, 1 times 1 is 1, 0 times 4 is 0. This is what you have, and that's the product in the LHS. What does this simplify to? This is 6 minus 1, which is 5. This is 9 plus 1, 10 minus 2, which is 8. And this is 14. This here is 0. What about the next element? This is minus 1. This here is 1. This is minus 1. This is 0. And this here is 1. That's the product in the LHS. That's the product in the LHS. What about product in the RHS? Let's simplify the RHS. Okay. So for RHS, once again, I multiply this with this. What do? I multiply these two together. How do I do it? Minus 1 times minus 1 will be this. 1 times 0 would be 0, and 0 times 1 would also be 0. This is what I get. And you may clearly observe that this here is minus 1. Okay, this here is 5. They are not equal, right? So at this stage also, you could say, even by writing only this and this, only that 5, that's solving this much, you can say the matrices are, the product of the two matrices on the LHS and RHS are not equal. That is something which you can comment on the basis of first row, first column only. But let's solve the complete matrix and then show you in detail. This is it. Then first row, second column, minus 2. Okay, 1 times 1 is 1, and 0 times 1 is 0. Okay, what next? This gets multiplied with this. Minus 1 times 3 is minus 3. 1 times 0 is 0, and 0 times 0 is again 0. This is what you have on the RHS, the first row. These are the elements present in the first row. Next, second row gets multiplied with the first column. 0 times 1 is 0, minus 1 times 0 is 0. So there are two zeros, and 1 times 1 is 1. Okay. 0 times 2 is 0, minus 1 times 1 is minus 1. This is 1 times 1 is plus 1. Okay. What next? The second row gets multiplied with the third column. 0 times 3 is gone, minus 1 times 0 and 1 times 0. This is all 0, 0, 0. What next? Let's take a look at the third column. Third row. 2 times 1 is 2, 3 times 0 is 0, 4 times 1 is 4. Okay, what next? 2 times 2 is 4. 3 times 1 is 2 and 4 times 1. Sorry, 3 times 1 is 3 and 4 times 1 is 4. Okay. What next? The last element over there is third row, third column. 2 times 3 is 6 plus 0 plus 0. This is 6 plus 0 plus 0. And what does this simplify to? Let's take a look at the final answer that we have on the RHS. This is minus 1, this is minus 1, this is minus 3, this is 1, this is 0, this is 0, this is 6, this is 11, this is 6. And can you see that LHS and RHS are obviously not equal over here? Are not equal. Therefore, LHS is not equal to RHS. That's the proof. It's proved. These two matrices are widely different, right? A lot of differences in these two matrices over here. Let us solve this question. 15th. Find a square minus 5a plus 6i. Okay, I is the identity matrix. If A is this matrix, okay, A is a 3 by 3 matrix. And for finding a square minus 5a plus 6i, A is already given. We'll have to find a square first. I is the identity matrix. We can simplify this complete thing. This will be a 3 by 3 matrix. But first we need to find a square. Let's do that. Let's try and find a square first. Right. Some of you, though some of you who are preparing for the IIT JEE examination would be familiar with something called, if you have studied matrices and determinants, you would be familiar with some concept called characteristic equation. I'm not discussing characteristic equation over here. What I'll be doing is I'll simply solve this equation in a simple manner. Right? Let's take a look at this. So is characteristic equation useful over here? No, characteristic equation is not useful over here. But questions similar to this involve characteristic equation at times for a matrix. Right. But let's focus on only solving this question for now. How do we solve this? So first I'll find a square. A square is simply a times a. A square is simply a times a. What is this equal to? This is this matrix 2, 0, 1, 2, 1, 3, 1 minus 1, 0 gets multiplied with this matrix only. This is 2, 2, 1. This is 0, 1 minus 1, 1, 3, 0. That's what we have. Let's multiply them together. The first row gets multiplied with the first column. 2 times 2 is 4. 0 times 2 is 0. 1 times 1 is 1. That's what you have. What next? This element over here is first row and second column. 2 times 0 is 0. 0 times 1 is 0. 1 times 1 is minus 1. First row, third column. 2 times 1 is 2. 0 times 3 is 0. 1 times 0 is 0. What next? The second row. 2, 1, 3 gets multiplied by 2 to 1. 2 times 2 is 4 plus 2 plus 3 times 1 is 3. Then this element 2, 1, 3 gets multiplied with 0, 1 minus 1. 2 times 0 is 0. 1 times 1 is 1. 3 times this is minus 3. The last 2, 1, 3 gets multiplied with 1, 3, 0. 2 times 1 is 2. 1 times 3 is 3. 3 times 0 is 0. This is what you have. Right? What next? This row gets multiplied with this. 1 times 2 is 2. Minus 1 times this is minus 2 plus 0. What next? 1 times 0 is 0. Minus 1 and 0 times 1 is 0. Right? This is what you have. Next, this row gets multiplied with this column. 1 times 1 is 1. Minus 3 and plus 0. That's what you have. A square, the value of a square can be obtained after this. A square would be equal to, this is 5. This is minus 1. This is 2. This is 9. This is minus 2. This is 5. This here is 0. This here is minus 1. This here is minus 2. Right? That's what we have over here. That's what we have over here, right? Okay. So what next? We have found a square. We already know a and we know I. So therefore, a square minus 5a plus 6i is equal to this matrix a square minus 5 times the matrix A plus 6 times the matrix I, and I'll help you with the matrix I. I is a 3 by 3 identity matrix. This is 1, 0, 0, 0, 1, 0, 0, 0, 1. Those are the elements. The diagonal elements are 1, 1, 1. Rest of the elements are 0, 0, 0 and again 0, 0, 0. So a square is, let's note a square from here first. A square is 5 minus 1, 2. This is 9 minus 2, 5. This is 0 minus 1 minus 2. Let's note a from the given question. 2, 0, 1, 2, 1, 3 and 1 minus 1, 0. Right? What next? Let's multiply this 5 together and 6 together and simplify the 3 matrices. What you get is, this is 5 minus 10. Ooh, 2 steps at one time, right? Let's not skip the steps. What I'll do is, I'll simplify. I'll write one more step, that is simplification, multiplication of this 5 together and this 6 together, and then we'll add and subtract. So what you get is, this is 5 minus 1, 2, 9 minus 2, 5, 0 minus 1 minus 2 over here, this is okay, right? Minus, what you get is, 5 times 2 is 10, 5 times 0 is 0, 5 times 1 is 5, this is 10, this is 5, this is 15, this is 5, this is minus 5, this is 0. Plus, what you have over here is, can you observe? This will become 6, 6, 6, rest all elements would be 0, 0, 0. This is what you will have. Right? That is all. We have one more step remaining. Let's add these two, right, and subtract this one. 5 plus 6, 11 minus 10 is 1. Yeah, simple, yes. Minus 1 plus 0 minus 0 is minus 1. These two are getting added, this is getting subtracted. 2 plus 0 minus 5. 2 minus 5 is minus 3 actually. Right? 9 minus 10 plus 0 is minus 1. Minus 2 minus 5 is minus plus 6. Okay, just a minute. This particular element. This is minus 2 minus 5 minus 7 plus 6. Minus 7 plus 6 would be minus 1. What was this element? 9 minus 10, which is minus 1. Okay, what about this element over here? This is 5 minus 15 plus 0. 5 minus 15 is minus 10. What about the third row? 0 minus 5 is minus 5 plus 0. What next? Minus 1 minus of minus 5. Minus 1 plus 5 plus 0. Minus 1 plus 5 would be plus 4. Minus 2 minus 0 plus 6. Minus 2 plus 6 is 4 actually. This is what I will be getting. So 1 minus 1 minus 3, minus 1 minus 1, 10, minus 10, sorry, minus 5, 4, 4. This is the final value of this expression, a square minus 5a plus 6i, as you can note over here. That is the answer for this question over here. Let us solve this question. If a equals this matrix, prove that a cube minus 6a square plus 7a plus 2i equals 0. Now, how do we go about proving this? Okay, what we'll have to find is a cube. We'll have to find a cube, yes, we'll have to find a cube. We'll have to find a square as well. Okay, so for finding a cube, obviously we'll need a square. So we'll find a square first, we'll find a cube after that. And a is given, I is obviously identity matrix of third order. And once we have found a cube and a square, we'll substitute them and get the value, prove this expression by substituting. Okay, so let's begin. We have the matrix A in front of us, and A square is simply equal to A times A. What does that give me? This is 1, 0, 2, 0, 2, 1, 2, 0, 3. Let's multiply this with 1, 0, 2, 0, 2, 1, 2, 0, 3. Let's multiply these two matrices together. What you have is, okay, 1, 0, 2, 2, 1, 3, 2, 0, 3. So this is 1, 0, 2 gets multiplied with 1, 0, 2. Can I write it in a single step? I think yes. We have practiced a lot of questions. This 1 times 1 is 1, 0 times 0, 2 times 2 is 4, 1 plus 4 is 5 actually, right? This is what you get. This gets multiplied with this. 1 times 0 is gone, 0 times 2 is gone, this is also gone, this is 0. So 1 times 2 is 2 plus 0 plus 6. 2 plus 6 is 8 over here, right? Keep checking the calculations. 0 times 1 is 0, 2 times 0 is gone, this is 2. Okay, 0, 0 gone, 2 times 2 is 4, this is 4 only. 0 times 2 is gone, 2 times 1 is 2, plus 3, 2 plus 3 is 5. 2 times 1 is 2 and 3 times 2 is 6, 6 plus 2 is 8. Okay, what next? 2 times 0 is gone, 0 times 2 is gone, 3 times 0 is gone, this is 0, very interesting. 2 times 2 is 4 plus 0 plus 9, 4 plus 9 which is 13. This is A square for me. This is matrix A square for me. Can we find A cube as well? Yes, A cube would be A square times A. A cube is A square times A, which can be written as, this is 5, 0, 8, 2, 4, 5, 8, 0, 13 times this matrix A. A is this matrix which is 1, 0, 2, 0, 2, 1, 2, 0, 3. Okay. And what is this product equal to? Let's find this product. This is 5 times 1, 0 times 0 gone, 8 times 2. 8 times 2 is 16 plus 5 is 21 over here. This is A cube for me. But next, this row gets multiplied with this. 5 times 0 is gone, 0 times 2 is gone, 8 times 0 is gone, this is 0. Okay. 5 times 2 is 10 plus 0 plus 24. 10 plus 0 plus 24 is 34. Second row gets multiplied with first column. 2, 0, 10. So 2 plus 0 plus 10 is 12. 0 plus 8 plus 0. 4 plus 4 plus 15. 8 plus 15. 8 plus 15 is 23. 8 plus 0 plus 26 is 34. 0 plus 0 plus 0 is 0. Okay. 16 plus 0 plus 39. 16 plus 39 is 55. You can observe over here, right? This is what I obtained. So this is the value of A cube. We already have A and we know I. So therefore, LHS is equal to A power 3 minus 6A square plus 7A plus 2I. This implies A cube. A cube is this matrix over here, which is 21, 0, 34, 12, 8, 23, 34, 0, 55. Okay, minus 6 times A square. So one of the approaches, one of the steps that I can write here is, let's multiply 6 with this A square directly and write that matrix. So are we skipping a step? Yes, we can skip that step, I suppose. Yes. 6 times this 6 5 is 30. 6 times 0 is 0. 6 times 8 is 48. Okay. What next? 6 times 2 is 12. 6 times 4 is 24. 6 times 5 is 30. 6 times 8 is 48. 6 times 0 is 0. 6 times 13 is 78. That's what we have, right? What about this 7A plus 7 times A? 7 times this matrix. Can I write them by multiplying together? Yes. 7 times 1 is 7. 7 times 0 is 0. 7 times 2 is 14. 7 times 0 is 0. 7 times 2 is 14. 7 times 1 is 7. 7 times 2 is 14. 7 times 0 is 0. 7 times 3 is 21. This is my matrix over here. What else? 2 times the identity matrix remain. What is the identity matrix? 1 0 0 0 1 0 0 0 1. This is my identity matrix, which is of third order. This is I3, right? That is what is required over here, right? And multiplying that identity matrix is by 2, what you get is, this is 2 0 0 0 2 0 0 0 2. This is what I'll get. Right. What else? Oh, just simply add these matrices together and see what you get. This is 21 minus 30 plus 7 plus 2. So 21 plus 7 is 28 plus 2 is 30. Minus 30 is actually 0. Right? This is what you are getting. In the first column, what about this element? 0 minus 0 plus 0 plus 0. That's all 0, 0, 0. Okay, this will be 0. 34 minus 48. 34 minus 48 would be minus 14. Plus 14. Okay, that becomes a 0. Plus 0 is 0 only. First row is completely 0, yes. Oh, we were supposed to prove this equals 0 matrix. Yeah, therefore we are getting a 0. In the second row also we should get a 0. Let's see, are we getting a 0 over here? Yes or no? Let's take a look at this. 12 minus 12 is 0, plus 0 and plus 0 will be 0. 8 minus 24. 8 minus 24 is minus 16, plus 14 is minus 2, plus 2 is 0. Yes. What else? 23 minus 30 is minus 7, plus 7 is 0, plus 0 obviously 0, right? 34 minus 48, okay, 34 minus 48 is minus 14, plus 14 is 0, plus 0 will also be 0. 0 minus 0 plus 0 plus 0, next is 0 only. And this element, 55 minus 78, 55 minus 78 would be minus 23, plus 21 would be minus 2, plus 2 which is 0 over here. And yes, LHS is equal to this is 0, which is the 0 matrix, which is equal to the RHS, hence proved. So this here is actually the I matrix and this here is the 0 matrix of whatever order is compatible with this equation, that is order 3 matrix, just order 3 by 3. Identity matrix and order 3 by 3 is null matrix, as you can see. That's the complete proof. Yes, we find a square first, we find a cube first, and therefore we can solve and prove that this LHS will be equal to this RHS. And that is all in this question over here. Let us take a look at this question. 17th, if A equals this matrix and I equals this matrix, find K so that A square is equal to KA minus 2I. How do we approach this question? This question is maybe based on something called a characteristic equation. Now, characteristic equation is not something which we are dealing with over here. I'll solve this question directly. Now, how do I solve this question? Let's take a look at this. A is this given, I is this matrix, I is the identity matrix of order 2. Find K such that A square is equal to this. So first I'll find A square and I'll write this equation, complete equation, and then solve for the value of K. Okay. So let's find A square first. A square equals 3 minus 2. Basically A square is simply A times A. What is that? 3, 4, minus 2, and this product with 3, 4, minus 2, this matrix. What do you have in this case? This is 3 times 3, which is 9, minus 8. Okay, this is what I have. What next? This is minus 6 and plus 4 over here. This is 4, 3, 12, minus 8 over here. This multiplied with this will be minus 8 and plus 4 over here. This is the matrix that I'll be having. This is 1, minus 2, 4, minus 4. That's a matrix A square for us. That is a matrix A square for us. Okay. Once you have A square, then give an equation. Given A square is equal to KA minus 2I implies, what is A square? This is 1 minus 2, 4 minus 4. Is equal to K times matrix A. Now what is matrix A equal to? Matrix A is 3 minus 2, 4 minus 2. Minus 2 times matrix I, which is 1, 0, 0, 1. This is what we have, right? There's only one variable involved. And how many equations do you think you're going to get? As you may observe over here, by comparing this position over here, 1, 1, you will get an equation in terms of K, right? By comparing this also, you'll get an equation in terms of K. By comparing each element, there will be 4 equations in terms of K. Okay, now if we have 4 equations in terms of K, all those 4 equations for a possible solution should give, all those equations should give the same value of K so that a solution exists. If the 4 equations give different values of K, even if one of the values of K is different, this LHS and RHS will not be equal, and in this case those equations would be called inconsistent system of equations. thereby telling us that there's no solution for this, right? So if we solve all 4 equations and get the same value of k, that will be my answer for the value of k, and let's see what we get. Can we simplify one step further before we write the equations? Yes, we can do that. 1 minus 2, 4 minus 4 is equal to k times 3. Okay, this is actually, let's multiply with k. 3k minus 2k, 4k minus 2k. Okay, and this is minus of 2002 over here. This is what we have over here. Therefore, 1 equals 3k minus 2. By comparing the first row, first column elements, this is 3k minus 2, which is equal to 1. Okay, let's solve for this, for the value of k. We can solve this. This gives me 3k equals 3, which gives me k equals 1. Okay. Can we solve for the first row, second column? Yes. This is minus 2 equals minus 2k minus 0. What does that give me? K equals 1. That's okay. That's okay. K equal to 1 is okay, right? And this element 4 equals 4k minus 0, which gives me again k is equal to 1. This is good. This was good. The equations are consistent up till now. What else? This is minus 4 equals minus 2k minus 2. So that gives me minus 4 plus 2, which is minus 2. Minus 2 is equal to minus 2k, which gives me k equals 1 again, which is also okay. All 4 equations are giving me the same value of k, that is equal to 1. And once I do that, therefore, the final answer is k is equal to 1 for this equation. There was a possibility of some error maybe, but then yes, this particular equation has a solution. The value of k that we obtain is 1, as you can see over here completely, right? Is that all? Yes, that is all for this question over here. Let's discuss this question. If A equals this matrix and I is the identity matrix of order 2, show that this matrix is equal to this matrix times this big matrix. Okay, that's what we are supposed to prove, show that, right? How do we approach this question? We'll have to simplify the LHS and RHS separately. Let's try to do that. Okay. So, what do we have in the LHS? LHS is I plus A matrix. What is I matrix? I is identity matrix of order 2. That will be equal to 1, 0, 0, 1. What is the matrix A equals to? A is equal to this 0 tan alpha by 2 minus tan alpha by 2, 0. This is my matrix A. Let's multiply them together to get the value of LHS. This 1, 0 gets multiplied with this. 1 times 0, 0 times tan alpha gives gone 0. 1 times minus tan alpha by 2, 0 times 0 would be minus tan alpha by 2. 0 times 0, tan alpha by 2 would be this. And 0 times minus tan alpha by 2, 1 times this is actually completely solved. This is pretty easy, right? I plus A is pretty simple. Just a minute. We were supposed to find I plus A, not I times A. Oh, bad. This is I plus A. We're supposed to find I plus A in the LHS, right? We have to add these matrices, not multiply these matrices. Okay, let's add them. 1 plus 0 is 1. 0 minus tan alpha by 2 is minus tan alpha by 2. This is 0 plus tan alpha by 2, which is tan alpha by 2. This is 1 plus 0, which is 1. This is what I have, right? Sum of the matrices I and A. It's not product. Let's not miss that plus sign over there. What else? In the RHS, we have I minus A times this matrix. Okay. So the RHS has I minus A times this matrix over here. What does that become? This is I minus A. Now this minus this, can I write that directly over there? Yes. 1 minus 0 is 1. 0 minus of minus becomes tan alpha by 2. 0 minus tan alpha by 2 would be minus tan alpha by 2 over here, and 1 minus 0 would be 1 over here. This is the matrix. And what's the other matrix? The other matrix is cos alpha. minus sin alpha, okay, sin alpha and cos alpha. That's what you have, right? That is the RHS for us. Okay, let's multiply. Now here we have to multiply these two matrices. As you can see, there's a product sign over here, right? There's a product over here, and yes, therefore these matrices have to be multiplied together. Let's do it. This is 1 times cos alpha, which is cos alpha, tan alpha by 2 times sin alpha. This is plus tan alpha by 2 times sin alpha. Okay, this is what you get. We'll require some kind of a trigonometric simplification. Yes, we'll do that. We'll do that. What else? This one gets multiplied with this minus sin alpha, tan alpha by 2 times this plus tan alpha by 2 into cos alpha. This is what I have. This is the matrix that I am obtaining. What else? In the second row, what you get is minus tan alpha by 2 times cos alpha. Okay, plus sin alpha. What about that term over there? That term would be minus tan alpha by 2 minus sin alpha, which will be sin alpha times tan alpha by 2. Okay, plus cos alpha. Pretty interesting. How do we simplify these terms? How do we go about simplifying these terms? Let's take a look at that. Tan alpha by 2. Now what is tan theta equals to? Tan theta is actually equal to sin theta upon cos theta. Yes. So I can write tan alpha by 2 as sin alpha by 2 upon cos alpha by 2. Okay. What's the big deal in that? That's no big deal. But once I write this sin alpha by 2 upon cos alpha by 2, we can take the LCM of this, right? Okay. So there's a cos alpha by 2 in the denominator over here. Yes, that's what I mean to say. There's a cos alpha by 2 in the denominator over here, and let's simplify this term. So sin alpha by 2 by cos alpha by 2, what will that be? We'll take the LCM cos alpha by 2, and this becomes cos alpha by 2 plus this numerator is sin alpha by 2 sin alpha, right? Take a look at this term very carefully. Take a look at this term very carefully. What you have in the numerator is cos alpha by 2, sin alpha by 2 plus, right? So this is cos A cos B plus sin A sin B. What is that equal to? Cos A cos B plus sin A sin B is actually equal to cos of A minus B. Okay. So this term here in this first term here can further be simplified and written as this term. Let me write it over here. This term can further be written as cos of A minus B, which is cos of alpha minus alpha by 2. What you have in the denominator is cos alpha by 2. Cos of alpha minus alpha by 2, what is that? Cos of alpha by 2 in the numerator and cos of alpha by 2 in the denominator. And yes, that is equal to this one over here. Okay, the LHS and RHS first terms seem to come out to be equal, right? Similarly, we can simplify the other terms as well. Yes, let's try to simplify this term. What you have is minus sin alpha. Tan alpha by 2 can be written as sin alpha by 2 by cos alpha by 2, right? Let's take the LCM as cos alpha by 2 over here. Denominator, in the denominator we'll have again cos alpha by 2, right? This is sin upon cos. This will be sin alpha by 2 cos alpha over here. What about this term? In the denominator you had cos alpha by 2. On taking the LCM, this will become minus sin alpha cos alpha by 2. Listen to what I am saying carefully. This is minus sin alpha cos alpha by 2 plus sin alpha by 2 cos alpha, or read it as sin A cos B cos A sin B. Sin A cos B minus cos A sin B. Sin A cos B minus cos A sin B sin A minus B, right? So this will become sin of alpha minus alpha by 2. In the numerator, denominator divided by cos alpha by 2. Yeah, this is the denominator. That is all. Yes, that is all in the numerator. Now what does this simplify to? This is sin alpha by 2 upon cos alpha by 2, which is actually tan alpha by 2. Which is actually tan alpha by 2. Okay, there should be a minus tan alpha by 2. Did we make any mistake? Yes, this is actually, okay, just a minute. This sin A cos B cos A sin B. So this should have been cos of sin of alpha by 2 minus alpha. Since we have written sin of alpha minus alpha by 2, we'll multiply it with the minus. What is sin of minus theta equals to? Sine of minus theta is equal to minus of sine theta, right? So that's what you get. This is what you get. Is that all? Yes, this is minus sine alpha by 2 upon cos alpha by 2, which will become minus tan alpha by 2, as you can see over here, right? What else? There are two terms which remain. Let's simplify them as well. This is minus tan alpha by 2. Again, I'll take the LCM, which is cos alpha by 2. This becomes minus sin alpha by 2 cos alpha. Plus, the cos alpha by 2 will go over there. This is cos alpha by 2 sin alpha. That's what you get in the numerator. This is sin A cos B minus cos A sin B. Okay. Now in this case, it is sin alpha cos alpha by 2 minus cos alpha sin alpha by 2, which is sin of alpha minus alpha by 2. This is sin of alpha minus alpha by 2 over cos alpha by 2 here. Right? This is what you get. Right? This is what you get. This is sin of alpha by 2 cos of alpha by 2, which will convert to tan alpha by 2. Yes. What else? The last term also will be actually convertible. Yes. Let's take the LCM over here as well. This is cos alpha by 2. Yes. What about the numerator? Sin alpha by 2. In the denominator, you had a cos alpha by 2. On taking the LCM, that will go over there. This will become cos alpha times cos alpha by 2 plus sin cos alpha by 2. And on seeing this, what you have is this is cos A cos B plus sin A sin B, which is cos of A minus B, cos of alpha minus alpha by 2. In the denominator, you have a cos alpha by 2. Yeah, that will remain as it is. And what you obtain is, this is cos alpha by 2, this is also cos alpha by 2, both will get cancelled, this is becoming 1. So it will be equal to 1. Right, yes, we have compared each and every term. This matrix over here is equal to this matrix, hence proved. That is one more step you can write over there. This is equal to this matrix, and that's the complete proof for this question over here. Yes, you can note the complete proof. This is question 18 from exercise 3.2. Pretty interesting, yes. Some long calculations, some simplifications, some trigonometric simplifications are involved over here. And let me get aside for a bit for you to take a look at the complete solution once again. That's all? Yes, that is all in this question over here. Let's discuss this question next. 19th. What does this question say? A trust fund has rupees 30,000 that must be invested in two different types of bonds. Okay. The first bond pays 5% interest per year and the second bond pays 7% interest per year. Okay. Using matrix multiplication, determine how to divide rupees 30,000 among the two types of bonds. Okay. If the trust fund must obtain an annual total interest of, in first case, there's annual total interest required of 1800 rupees. In the second case, annual total interest required is of 2000 rupees. Now, such a question has been asked before as well from you in different classes in a different form, right? Different classes in the previous classes, that's what you can say. This particular type of question can be solved by forming linear equation in one variable as well as by forming linear equation in two variables. Now, how do we approach this kind of a question? Let's take a look at this. We'll talk about matrix multiplication at a later stage, but first let's take a look at the idea behind this question. What do we have? Trust fund has rupees 30,000 that must be invested. So one amount can be X. Let first part is X. The second part can be 30,000 minus X, right? That's what you have, right? Two different types of bonds. The first bond pays 5% interest. This bond pays 5% interest. This bond pays 7% interest. Okay. And on adding the interest, what we get is the total interest, which is 1800, right? That's what we are supposed to do. So this interest would be actually equal to X times 5% of X, basically 5% of X, that will be equal to X times 5 by 100, right or not? Yes, 5% of X is 5 by 100 times X. 7% is 7 by 100 times 30,000 minus X, right? This is what we have. And that sum total should be equal to 1800. That's a simple linear equation that we obtain, and by the concepts which we already know. But then using matrix multiplication, how to represent in form of matrix multiplication? So what you can do is, we can form matrices. So let's form matrices first. Let amount invested in the two types of bonds in bond 1 is x implies bond amount invested, amount in bond 2 is 30,000 minus x. That's what you have, right? Implies amount invested in bond 2 is 30,000 minus x. Okay. What else? The interest in each of these is 5% and 7%, and 5% can be written as a fraction 5 by 100, right? That's what we'll do. So by using matrix multiplication, what we have is interest. The total interest will be equal to what? The total interest would be actually equal to, we'll have to multiply this matrix of the terms containing this x and 30,000 minus x by the corresponding rate of interest, right? That's what we'll do. So one value is x, the other value is 30,000 minus x, and this has to be multiplied by, as you may clearly observe, this has to be multiplied. The total interest would be x times 5%. 5% is actually 5 by 100. 30,000 minus x by 7%, which is actually 7 by 100. And multiplication, as you may recall, multiplication for matrices is row by column multiplication. This row gets multiplied with this column. This is a 1 by 2 matrix. This is a 2 by 1 matrix. This product will be a 1 by 1 matrix, which will be equal to the total interest. X times 5 by 100 and 30,000 minus x times 7 by 100. That will be the total interest, right? That will be the total interest. And now, can we solve the first part? Yes, we can solve the first part very easily. After this, let's move ahead and solve the first part. For the first part, what we have is x 30,000 minus x times this matrix over here is 5 by 100. The other matrix over here is 7 by 100. And this interest is actually equal to what? This total interest is equal to 1800. Okay, this is a matrix, 1 by 1 matrix. On solving, let's multiply. This is 5x over 100 plus 7 times 30,000 minus x over 100 is equal to 1800. That's what you obtain, right? This is the equation that you get. Can you solve this equation to get the value of x? Yes. Which implies, what you get over here is 5x upon 100, this 100 and 100. We can take this 100 from LCM and bring it on the right hand side. We get 5x plus 7 times 3 is 21. Okay, there are 4 zeros. Let's add 4 zeros over here. Okay, then there is minus 7x, and which is equal to 1800 times 100, which will be this 1,80,000 over here. What next? What next? You observe that this 5x minus 7x is minus 2x on the LHS. In the RHS, what you get is? In the RHS, what you get is 1,80,000 minus 2,10,000. What is that? Minus 30,000. This is minus 30,000, and therefore x is equal to 15,000. Okay. Now, since x is equal to 15,000, that is the amount invested in bond 1. What is the amount invested in bond 2? This is amount invested in bond 1. What happens in case of bond 2? Bond 2 amount is 30,000 minus x, which is 30,000 minus 15,000. What is that equal to? 30,000 minus 15,000 is again 15,000. So basically, you are dividing the amount in 2 equal parts for getting this investment, this return of total interest of 1800. That's what you are doing, right? This is part A for us. What happens in case of part B? In case of part B, this particular part exactly remains same, and we can solve from here. In the part B, what you have is this value changes, right? This right hand side value changes actually. In part B, this matrix, this total interest is actually equal to 2000, as is asked in this question, right? This total interest is equal to 2000, and what are we supposed to do? This is 5x over 100 plus this times this is 7 by 100 times 30,000 minus x, which is equal to 2000. And let's solve this further. Let's solve this equation further. what you get is, let's bring this 100 on this right hand side, and what you get is 5x plus 210,000. This is 2,10,000 minus 7x is equal to, what you obtain on the right hand side is 20,002 times. There are 5 zeros on the right hand side, right? 2000 and 00, right? That's what you get. This 100 comes on the right hand side. So this is giving me minus 2x is equal to, this is 2 lakh and this is 2,10,000. This will be minus 10,000 actually. And from here, the value of x that you obtain is simply 5,000. Okay, and this is the amount invested in bond 1. What is the amount invested in bond 2 in that case? Bond 2, the amount invested in bond 2 will be 30,000 minus x, which is equal to 30,000 minus 5,000, that is 25,000. This is amount invested in bond 2. And yes, that is the division of that amount 30,000 to get this interest 2,000. Right. Is that all? Yes, that is the complete solution for this question over here. Okay. Could we solve this question in any other way? Yes, this question could have been solved in another way. We could have used two variables. Probably we could have used two variables. What are the two variables? In case of using, instead of using basically x and 30,000 minus x, we could have said, okay, let's divide the amount 30,000 in two parts, which are x and y. Okay. What are the equations? The equations in that case would look like, let amount in bond 1 and 2 be x and y respectively. This is rupees x and rupees y respectively. Okay, so in this case, x plus y would be equal to 30,000, right? That's one of the equations. The other equation is rate of interest. With regards to rate of interest, that 5% interest and 7% interest would be available on amount x and amount y respectively. Okay, so what do we have in this case? X, y get multiplied with, first of all, 1 and 1 to give us, this is 1 by 2. They also get multiplied with 5 by 100 and 7 by 100 for the interest. Okay, x plus y would be actually equal to 30,000. Since we want that x plus y is 30,000, that amount is already fixed, and interest in the first case would be 1,800. Okay, whereas interest in the second case would be 2,000. So this is for A part, we'll solve this equation, and for B part we can replace that 1,800 by 2,000. Right? This is an alternative approach that we can follow for this same question, and once again solve this. So let me solve this part A for you. Part B, I think you can manage. For the alternate approach, you can manage on your own, right? Replace that 1,800 by 2,000. So let me solve this one. What does this give me? This multiplied with this. This is x 1 times 1 by 2, 2 by 2 is what gives me 1 by 2 matrix. This is this. This is 5 by 100 x plus 7 y by 100, and this matrix over here is equal to 30,000 and 1,800 over here. This is what is equal to. So from here we observe that x plus y is 30,000 and 5x plus 7y upon 100 over 100 is equal to 1,800. Okay, pretty interesting. The second equation can further be written as, simplified as 5x plus 7y is equal to 1,80,000. Is it? Yes, this is what you get. Note this carefully. Yes, this is 1,80,000 and x plus y is 30,000, right? This is equation number 1 and this is equation number 2. Using equations 1 and 2, I can solve the remaining, I can do the remaining calculations over here, and we can get the values of x and y. How do we get x and y? Let's multiply this equation by 5 and subtract. So 5x and 5x will get cancelled. 7y, 5y can be subtracted to give us something. Let's observe. So equation 2 minus 5 times equation 1. That gives me 5x minus 5x is gone, 7y minus 5y is 2y, which is equal to 1,80,000. This is what we have, minus 30,000 times 5, which is 1,50,000. This gives me 2y equals 30,000, or y equals 15,000. If y is equal to 15,000, then using equation 1, from equation 1, we get x is equal to 15,000 again. And yes, that is my answer. That is, the amount invested in bond 1 is 15,000, amount invested in bond 2 is 15,000 once again. And that's the complete solution for this part A using this alternate approach. Part B is something which you should be able to manage with this kind of approach as well, right? We have solved using one approach already. So I think that is all for this question over here, right? Let us take a look at this question, 20th. The bookshop of a particular school has 10 dozen chemistry books, 8 dozen physics books, 10 dozen economics books. Okay, the selling prices are rupees 80, 60 and 40 respectively. Find total amount the bookshop will receive from selling all the books using matrix algebra. Okay, let's try to do this. So there's only one bookshop, okay, and some number of books are there, okay, and their selling prices are also there, right? So let's create matrices for representing the number of books for that matter. Number of books, particular school has 10 dozen chemistry books. We have chemistry books, we have physics books, and we have economics book. Okay, let's write in short. And how many books do we have over here? There's only one school, right? The bookshop of a particular school has 10 dozen chemistry books, 8 dozen physics books and 10 dozen. We are talking about dozens, right? How many books are there in a dozen? In a dozen there are 12 books, right? A dozen is equal to 12. You may remember that, right? 1 dozen is equal to 12. 12th number, right? Whatever. A dozen bananas is equal to 12 bananas, right? We have, in case we have, let us say, a dozen of anything, right? Dozen and score or something. So one score is equal to 20 elements, right? That's what we have. So similar terms and used at different places. Next, the selling prices are rupees 80, rupees 60 and rupees 40 each respectively. Okay. For chemistry, physics and economics, we have selling prices. So these are numbers basically. Here we have numbers in dozen, right? And the next thing is prices, and the prices can be written in this particular manner. Prices, these are selling prices. Selling prices. Selling prices of each book is 80 for chemistry book and 60 for physics book and 40 for economics book. Chemistry, physics and economics. So these are two matrices representing the number of books and the corresponding selling price of each book, right? Total amount the bookshop will receive from selling all the books. That's what you are supposed to find. Now total amount will be equal to product of these two matrices, right? But here the numbers are in dozen, here the numbers are in units, right? 1 dozen is equal to 12 units. So what you'll get is basically each of this particular matrix has to be multiplied by 12. 12 times this matrix, which is 10, 8, 10. Times the other matrix for getting this product, right? 80, 60, 40. Had there been another bookstore in the school, or had there been another school, we would have added one more row for that particular number of chemistry, physics and economics books in that particular, let us say, bookshelf, bookstore or school. Had there been more number of schools, we would have added more number of rows. The prices obviously could have remained the same, 80, 40, 60 and 40 in that case, right? And by multiplying, we would have obtained the total amount for first, second and third schools. So what do you have over here is, this is 12, okay, and this becomes 800 plus this first row gets multiplied with the first column, and what you get is 800 plus 8648 plus 400. This is what you get. What is that? 1680. 12 times 1680. This is what I am getting. right? This is what I'll be getting. 12 times 1680 would be actually equal to 12 times 0 is gone, 12 times 8 is 96, 6, 9, and 12 times 6 is 72 and 9 is 81, 1, 8 carry, 12 times 1 is 12 plus 8 is 20. This is 20160. That's the total amount the bookshop will receive from selling all the books using matrix algebra, as you can see, right? That is all for this question over here. Let's discuss this question. Assume X, Y, Z, W and P are matrices of order. Some orders are given for different matrices. 2 by N, 3 by K, 2 by P, N by 3 and P by K respectively. Okay. Choose the correct answer in exercises 21 and 22. Okay, we're supposed to solve this 21 and then there will be another 22 somewhere. So the restriction on N, K and P so that Py plus Wy will be defined are. There are 4 options given and we are supposed to choose the correct option for defining this product and the sum further, sum of the products. So restriction on N, K and P so that Py plus Wy is defined, will be defined are. Okay, what is the order of P? Let's write the different orders first. What is the order of P? P. So let me write the orders first. The order of X is 2 by N. The order of Y is 3 by K. The order of Z, W and P. That's what we are interested in. The order of Z, 2 by N, 3 by K, 2 by P and N by 3. Then you have P by K. Okay, let's not make any mistakes in this. So first we need P. P is P by K. Okay. Y is 3 by K. Okay. W is N by 3 and Y is 3 by K. This is what we are interested in, right? So let's try to observe these orders and guess the values. Let's see. For defining this Py, okay, the restriction on N, K and P so that this will be defined. This should be defined. For that to happen, this product should be defined, this product should be defined, and they should be, the addition should be possible of these 2 matrices, right? Right. So for the products to be defined, these 2 numbers should be equal, right? The number of columns in this should be equal to the number of rows in this, and these 2 numbers are equal, should be equal. So from here we obtain that K equals 3. 3 is equal to 3, which is okay, right? So from here we obtain the value of K, which is equal to 3. That's okay. What else? What else? The final order of the product would be this, P by K. And the final product would be N by K over here. P by K and N by K, the orders should be exactly same for the sum to exist. So from here we observe that P equals N. This P should be equal to this N. This K and this K are obviously equal. The order should be exactly same, right? 3 by 2 can be added with the 3 by 2 matrix. 2 by 3 can be added with the 2 by 3 matrix. But any other possibility? That's not possible. 2 by 3 cannot be added with any other order except for 2 by 3, right? So P by K can be added with a P by K matrix. Okay. So P should be equal to N. And this is one condition, this is the other condition. There are only 2 conditions that we obtain, the restrictions basically, that's what we obtain. So K equals 3 and P equals N. K is arbitrary? No, K is fixed. P is arbitrary? Yes, P can be arbitrary, but N has to be equal to P. That's also important. K equals 2, P is equal to 3, K is equal to 2. No, D is not correct, as you may observe. K equals 3 is okay, but P is not arbitrary. P is equal to N. K is arbitrary? No. K equals to 3 and P equal to N. That is the correct option. That is option A for this question. The answer is option A, as you can clearly see with regards to this question over here. Next question which we have is based on information. As you can see, X, Y, Z, W and P are matrices of some given orders respectively, and choosing the correct option out of the 4 given options is what we are supposed to do for this question. If N equals P, then the order of the matrix 7x minus 5z. We are interested? 7x minus 5z. Now multiplying with scalars will not have any impact on the orders. The order of x is important. What is the order of x? The order of x is 2 by n. What about the order of 5z? Will be same as order of z, which is 2 by P. As you can observe, this is 2 by P. Okay, what next? If n equals P, so for this difference to be defined, difference or sum to be defined, what is the important condition is, the order should be exactly same. So for that, n should be equal to P. If n is equal to P, then this difference will be defined. If n equals P, then order of the matrix this. So we are interested in the order of this. The order of this would be this or this, both are same. So 2 by n is the order, or 2 by P is the order, because n and P should be equal. This is important, right? So order would be either 2 by n or 2 by P. 2 by n seems correct, yeah? 2 by n is the order of this. P by 2, no? 2 by n is the correct answer for this question. It's pretty simple. As you can see in front of me over here. Right? That is all in this question over here. And with this, we come to the conclusion of this exercise, exercise 3.2 from Matrices, class 12th, chapter number 3. Okay? NCERT discussion of exercise 3.2 is what we have brought to you in this session. In the next session, we'll be talking about another exercise. Till then, all the best.